Vlad and Delbert. Yeah, I'm here to talk about cats. But a little bit before we get into it, I'll say a little bit about who I am. My name is technically Michael O'Connor, but no one ever calls me Michael O'Connor except for my mother. So everyone else calls me Stu. If you want to know why people call me Stu and not Michael, you can ask me some other time. It's a pretty good story. But I work in San Jose for Verizon. And like I was saying before, we are hiring. We're always hiring. We do a lot of Scala work there. We have certainly into triple digits of Scala developers, and we have stuff. We have people at all levels. We have people that are new to Scala who are coming from Java. We have some very well-known, very skilled Scala developers. People like Runar and Tim Parrott and stuff. That people who are pretty well known. And we're doing stuff, we're doing some big data stuff, we're doing some little data stuff, we're doing some enormous data stuff, we're doing a lot of stuff with video, we have projects all over the place. So yeah, please come find me afterwards if you think you might want to work with us. We have, like I said, we have positions for just about everyone. So a little more about me and my path to landing, I guess, on stage here is that I've been working in Scala for I guess it's about 4 years now. I had done Java for years and years and years and years, and then I had gone off into doing Python and Perl and PHP and a little bit of this, a little bit of that. And then a buddy of mine said, hey, you remember that cool functional programming stuff we did in college? I'm actually getting to do that for real at work. You should check out this language, Scala. And I did, and I got hooked instantly, and I started playing with Scala. Seemed like 24 hours a day, and when I started doing Scala stuff, I very quickly kind of found my way over to the Scala Z community. And the reason for that, I think, was that when I went and hung out in the Scala Z IRC room, I was instantly the dumbest guy in the room, which was great because it meant I was learning a ton. And I got really excited about the stuff they were doing at Scala Z and functional programming in general. And the things that are exciting to me were how, I had come from this big object-oriented, heavy-handed design, the object-oriented concepts of building these big design patterns. And you have this, factory pattern, visitor pattern, all this stuff you get out of the Gang of Four book, where, people were architecting these very large structures of code that would, with the promise of modularity and the promise of reusability that was never really realized because it doesn't, I think it's a false promise, but I think it's one that's delivered on very well by functional programming. And I was excited to see when I moved from people saying, well, I'm going to abstract over this pattern and this and that. I moved into the Scala Z world and they were doing stuff like, how do we loop, how do we not use if statements and stuff that was so fundamental and low level that it seemed like there must be some bigger picture, and I think there really is. So I got, I got very excited and got very involved in the Scala Z community and became, a contributor. And I sent a lot of patches out to Scala Z, most of which ended up being oriented towards documentation and examples and stuff like that, because that was where Scala Z was kind of lacking the most, as far as I'm concerned. Because it's a library. So just to get an idea of who I'm talking to, who in the room knows about the Scala Z project or knows what it is? Okay, fantastic. That's great. How many people are using Scala Z? Okay, that's great. That's more than I would have hoped for. So that's fantastic. So how many people found that Scala Z was a difficult library to start to use? Right. More people than said that they're using it, which I think is somewhat telling. That's the type of thing that I tried to help out with Scala Z. And then, there was a lot of, in trying to make Scala Z more approachable and more, trying to maybe say, maybe we should have more documentation, or maybe we should change some of these names around to be more easy for people to understand. There's a lot of resistance to that in the Scala Z community. There are people who believe that no, you don't need documentation. If you need documentation, you need to learn how to read the types better. Or there's a lot of people who say that a variable name that's one letter is just is good enough for anybody, that kind of stuff. And so, you know, there is some resistance to doing that. There was, and the risk of getting into a touchy subject, there was a bit, some of these issues and other social factors kind of led to a bit of a, let's say, schism in the Scala Z community. And there is, I could probably talk for hours about what exactly happened and get myself into a lot of trouble and receive a lot of hate mail the next day if I were to get into that. So if I'm going to get into that, I encourage you, if you're interested in it, to try and dissuade yourself from being interested in it, because it's just a time sink and there's nothing useful to get out of there. But what happened? There was a schism, and the result of it was that people said, we need a new library. Let's think about what would we do. People started saying, you know, maybe Scala Z isn't for me, but I still need the stuff that exists in Scala Z. And a lot of people started thinking about, well, what, if we were to rewrite on Scala Z, what would it look like? And then it started happening, and that rewrite ended up being the CATS library. So I'm glad to see that a lot of people are familiar with Scala Z, so what you should think of is that CATS is a kind of a reimagining of the concepts inside Scala Z. So it's a library that tries to foster pure functional programming in Scala. Hopefully people have an idea about what it means to be pure functional programming in Scala. There's a very simple definition of what that means, which I really like, which came from my colleague Runar, who said that what functional programming is programming with functions. So, and to use that definition, you kind of have to be able to define what a function is. And what we're going to say is just, you know, a function is a pure mathematical concept. It's something that maps a set of possible inputs to an output. And anytime you give it an input, you give it the same output. And the only anytime you give the same, like I said, anytime you give the same input, you have to get the same output, and that lets us. That gives us a property called referential transparency, which lets us do a lot of reasoning about our code base. If we can make these promises that this function here doesn't touch the database, doesn't write to the console, doesn't mutate any memory, doesn't change anything, all it does is use its inputs to produce an output. There's a lot of benefit we can get there's a lot of benefit we can get out if we write our code this way. If you want to write your code this way, what I'm going to promise you you're going to do, if you try to write all of your code this way, I'm going to say I'm never going to do any of that stuff, which is fairly impossible because, again, at the end of the day, we do have to read from the database, or we do have to do something, but we have to write some output to the console or read from a file, and these are all things you're not allowed to do in the functional programming world. But what we're going to do is we're going to try and go as far as we can and push those things off as far away from the core of our code as possible. If you're going to program that way, I promise you that you are going to end up, at some point, starting to reinvent some of the concepts we have in Scala Z or in CATS. You're going to want some of the constructs we have, or if you learn what we've got, you might say, that's just like the thing I was doing the other day. I could use that. And then if you learn more and more of it, you start to use more and more of it, and it'll start to become more natural, but it'll make a lot of the process of writing code in a purely functional way will become simpler and easier to manage. So, and a lot of this stuff comes from things like category theory, and this is where we get all of the big scary words like monad and monoid and semi-group and all of these things, which I think tend to turn people off. And the reason they turn people off is that they are concepts which are so kind of general that there's not much to sink your teeth into, to grab hold of. And so you might learn that a functor is just an object which has a map operation. It takes A's and turns them into B's, and it's just like, okay, well, what's an A? And what's a B? How do I know? Sometimes it's just like, that's not enough. Give me a real world, and if you say to you, okay, it's like a list, where if you have a list of ints, and then you call the toString method on each int, you get back a list of strings, and then people can start to understand it. But the problem is that when you try to read some of the theory behind some of these category theoretical concepts, it is way too general, and it's just, like I said, hard to kind of sink your teeth into. So this CATS project was started by a guy named Eric Osheim, and I'm sorry to probably be mispronouncing his name, but he was the one who finally, when we were all sitting there going like, we need a new Scala Z, we need something different, we need to start over, he was the one that finally threw up in his GitHub repository and said, all right, here it is, I started. What do you think? Very quickly, it was clear that there was a big desire for something like this to happen, because after he announced that, the next week was just absolutely mind-blowing about how much people jumped right on and started contributing. I wrote this slide deck for a previous conference, which was over a month ago, so this number of 30 is probably wrong. There's probably closer to 40 contributors now. Anybody in the room contributed so far? Him? All right. Hopefully soon enough, some of you guys will help contribute. And I'll talk about how maybe you can contribute sometime soon. But in the first week, when it came, we merged 100 pull requests in the first week, which is just, which is crazy to think about. Some guy in his personal GitHub repos threw up, a couple definitions of here's how a monad might look like, here's what a functor might look like, and people went crazy. And how quickly it became a really well fleshed out library was pretty awesome. And it happened because, that what we did up front is that we set our goals about what we wanted the project to be, and very much right now up front, before we started, we had this agreement before we started writing a lot of code, which was, the agreements that we were about what we wanted the library to be like started well before anyone showed up before Eric showed up and said, okay, here it is, I started. We all had some ideas about what we wanted it to be, and that, we wanted to, there was a lot of things about, first of all, about what we wanted to change about Scala Z, but a lot of it was about how we wanted to form a new community. I took a lot of, in trying to think about what we wanted to do for a community, I took a lot of inspiration from the ZeroMQ project. It's a project I highly recommend you guys checking out. The ZeroMQ project is a cool project from a technical aspect. Like ZeroMQ is a very, very pleasant, very powerful set of concepts to work with. But what's really fascinating is that if you ask the guy who started the ZeroMQ project, if you were to go to him and ask him, what is the ZeroMQ project? First of all, let me tell you what I think the ZeroMQ project is. The ZeroMQ project is a networking library. It allows you to create things called sockets, which they're abstract. A socket could be a TCP connection, it could be a domain socket, it could be, it could be a whole number of different different kind of networking constructs to be put together to build a network. Fantastic. What Peter Hintians, I think his name is, but what Peter would say that the ZeroMQ project, if you asked him to describe the project, he wouldn't talk about networking at all. He wouldn't talk about software at all. He would tell you that the ZeroMQ project is a community of people that's run by the people. And it's a community of people where anytime we get a pull request, we merge it instantly. We'll figure out if it broke something later. And it's a community where if we have some bad actors, they're dealt with quickly. If there are people who are causing pain to other developers in the community, we deal with it very quickly. And so these are the type of things that he said, if you want to know what ZeroMQ is, you need to know that. And then later we can talk about the networking library that spontaneously arose from that community. And so this was the type of thing that I wanted to, a lot of the ideas that he had are ideas that I wanted to incorporate in Scala Z. So one of the first things we had, when we didn't have any way to even really use the library, we had a statement of code of conduct, and we had statements that said that we want to be inclusive and that we want to, if you're ever acting in our community and someone does something that makes you feel uncomfortable, I want you to come find me, or come find Eric, or come find go find Delbert, or any one of the people who are part of the project, and we'll get it sorted out. This is something that turned off a lot of people with Scala Z. There was a lot of people who said, I would use Scala Z, but every time I try to talk in that channel, people are belittling me, or telling me I don't know enough math, or telling me I shouldn't use a CatScore, or this kind of stuff. And so, what we wanted, one of my core goals of this project is to make it very approachable to people who are newcomers, and to make it also lower the bar to contributing. I'll talk more about how we're trying to do that a little later. But those, just like, I'm not going to go so far as to say, like, like the ZeroQ project, that the CATS project is about a community, and then a functional library came out of it. It's a functional library, but these things are very important to us. It's to make sure that we have a good community and people are friendly and working together. Part of what we want to do to make things better, make it a better library to work with, we're trying. It's great that I am not one of them, but we have several people on the project, especially Eric, who's the person whose GitHub it's under right now, the guy who started the project. Another coworker of mine, Cody Allen. Some of the other big contributors are some of the most anal retentive people I've ever worked with, which. Good for them, good for everybody. I'm not that guy, but they're the ones where you put in, you say, they're the ones who on my pull request are saying, I really like that you line those stars up on your Scala. Or, you name this here over this way, and you named it over here, like with this one has an S on the end, and that one doesn't. And I'm not merging it until you fix that. So everything is super consistent. Another thing that we're trying to do is we're trying to document everything. We're not doing so great at that right now. We were doing great at that in the very beginning. We slipped a little bit. But Delbert promised me he's going to start working on that soon, and I'm going to start working on that again soon. But we're trying to say that everything should be documented, even the stuff that some of the people in Scala Z would say, you never need to document this function. All you need to do is look at the types, and you know what it does. But we're saying that's not good enough, because when we ask people, when we say, hey, when you try to teach Scala Z to other people, what are their complaints? And this is one of their complaints, that there's no documentation. So we want Scala doc everywhere. We want examples everywhere. So what we'll get into later, when we talk about some of the differences between Scala Z and CATS, some of the differences are going to be that we want documentation for any of the stuff you're going to bring. So when you come to me and you say, I got this cool concept from category theory that I can implement in CATS, and here it is, I'm going to say, well, how do I use it? Show me an example. Until you have an example, I don't even want to touch this stuff. Because until you have an example, people don't know how to use it. So if people don't know how to use it, it's useless. My last bullet point is that we're very concerned about search engine optimization, which is why we picked such a great name like CATS. Which is actually, kidding of course, because CATS is a horrible name for trying to Google things. Because when you Google for CATS, you don't necessarily find Scala Z functional programming. Okay, so I want to talk a little bit more about I'm going to talk a little bit about what we've got inside Scala, inside CATS. And before, I labeled here that this stuff I'm going to talk about first is part of CatScore. And CatScore is, is the core module. One of the other things we're trying to do that's different from Scala Z is we're trying to keep things more modular. So we're trying not to just say that there's just one CATS project and we threw everything in there. We're trying to say, have a core project which has just the stuff that, just the type class synthesis, the things like what is a monad, what is a monoid, what is a semigroup, and then add a couple data structures like here's a semigroup for, or just there's the other data structures like here is a reader monad. Here are a couple specific monads which are in there because we need them to implement other parts of CATS. But then we're trying to keep separate from that, say, we're trying and failing in some places to say, let's keep like the type class instances for like, here's how a list is a monoid. We can't keep that stuff separate. Or we're trying to say, our implementation of the free monad and our implementation trampolines can go live over here. And the stuff that was in Scala Z, which isn't necessarily part of category theory, but stuff like, well, we could do a lot better than Scala.option. We could write a better option. Or we wish that list didn't have a head method, or we wish that list was invariant instead of covariant. That kind of stuff which has made its way into Scala Z, which a lot of people don't use. A lot of people who come to Scala Z are coming for the type classes, but they're not necessarily coming because they don't want to use Scala collection immutable list. They want to use our iList instead. So that kind of stuff is stuff that we've separated out. We're trying to keep things more modular, and it's a bit of a struggle, but so far we're going to strive for the modularity. So in CatScore, the things you'll find in there are kind of the usual suspects that you expect to find from Scala Z. So we have stuff like functors, applicative functors, monads, a traverse type class. And anyone who's used Scala Z very much is probably familiar with all these. And these, we have them in CATS. They should work just like you expect them to work in Scala Z. Maybe a couple minor method names have been renamed. Maybe a couple other things have been renamed. But this kind of stuff should be pretty intuitive and work just like it does in Scala Z. Some stuff that we don't have in directly is monoid and semigroup. These are things that we inherited from the algebra library. People aren't familiar with the algebra library. You'll see that it's is Eric Osheim's GitHub account. Algebra is a project he had started a few months earlier, and it was one where he was trying to get some interoperability between Spire and Algebird, which Algebird is. Spire is a library for mathematical operations that he wrote. It's one that lets you do things like add numbers, but add numbers and not care if they're integers or rational numbers or floating point numbers or complex numbers, and do other mathematical operations. But the idea was that Algebird had defined a lot of this stuff, like how do I add two numbers together, and Spire had added a lot of this stuff, and the two groups worked together to create algebra as being the lowest common denominator, so they could those concepts could be shared, and someone who's using Algebra can also bring Spire into a project and not have to pay the penalty of converting all my types from Spire land to the algebra land with this and that. So we are going to do the same thing, and so we grab our monoid and our semigroup, also our equality instances and stuff from the algebra project itself. There are some notable things which are missing from Scala Z. And this is, I think, one way that we're going to do a really good job at helping kind of the approachability of the language. And so there's a lot of things in Scala Z that you'll find, if you look through the Scala Z core library, if you go to, into the source code, into the core project, and just look through all the files in there. And I am a very heavy user of Scala Z. I've written a lot of the examples that are in the Scala Z project. I know the library very, very well. I would say that I've used Lens, but none of those other things I've used. In Con, there's a right con extension, a left con extension. There are distributive functors. There are, there are lots of these things that are in there that no one ever uses, right? Has anyone in the room ever used a con extension? Probably Vlad and maybe one other person might be able to tell me what a con extension is. And the same thing with representable functors. And a lot of these things came from people who are just, as an exercise, porting stuff from Haskell into Scala Z. And sometimes it's because we can. Sometimes it's to see if we can. Sometimes it's because theoretically you could use this stuff. But what we're trying to do is we're trying to say, no, not in CATS. Not in CATS unless you show me exactly how I'm going to use it. Unless there's some compelling reason why it's going to earn its weight inside CATS. So there's a lot of stuff right off the bat that we say, we're just not even going to bother with it. And I think this helps because I think that if you look at our core, if you look in the directory where we keep, where all the source code is for core, it's like 10 files in there. It's like when you look at it, you don't feel like, oh my god, I can't. What is this? You can really, you can look through it and it's stuff that's more familiar and it's not so intimidating. So I think it's a really good thing that some of this stuff is missing. And this is really, again, a very this is a pared down list. The list of things that we didn't include is huge. But I added some of these examples that say, a junction. Whoever's using a junction, that kind of thing. Lens is one that's very, very useful. Lens is a great concept, and Scala Z, I've used lenses in Scala Z quite a bit. People are starting to shy away from Lens, and there's the Monocle project, and it's kind of, everyone kind of thinks that the next generation, that Monocle is really the way to go. So I think that you'll even see lenses removed from Scala Z because they're not getting a lot of love, and all the love is going towards the Monocle project. So there's a few things that we have that are in Scala Z that you'd expect to see in CATS, things that are very usable and very approachable, but ones that we decided to rename. And we've tried to rename them to gain consistency, and in some cases, try to make things more approachable. So for some examples, there was a plus, there's a plus and a plus empty, and a monad plus and a applicative plus. These are all things which are related to functors that add monoid-like and semigroup-like operations to higher kind of types for applicative functors and monads, and we decided to rename them to try and be more consistent, to add the K to show that plus is really just a semigroup, but it's a semigroup that works over higher kinded types. That's going to fly over the heads of some people, but if someone wants to, that's something else I meant to say at the beginning of this talk, is that if anyone does want to stop me and get me to go into more detail on anything, I'm happy for you guys to walk up to the microphone and ask me a question. I don't mind stopping in the middle or explaining something in more detail. So please feel free. So like the bind operator, the bind type class, we renamed it to flat map because that's all it really is. The bind in Scala Z, all it does is it uses the name from Haskell instead of using the name from Scala. That's a little bit silly because then I have to always apologize for, well, it's called bind in Haskell, but really it's flat map. That's all. That's the only thing, the only operation that's on bind, so we figured we might as well name it flat map. Same with co-bind and co-flat map. Then the three at the bottom are subtypes. These are all three of the things at the bottom are things that are similar to an either in Scala. So in Scala, I assume that most of you are familiar. You have an either type, which is something that's either the left or it's the right. It's kind of like an option, where an option is either there or not there. But a lot of people use either for it's there, it's on the right, or it's not there, and here's why. It's a successful value or a failure value. Is the most common way to use. The big drawback of Scala's either is that it's not biased, in that it doesn't treat the right value differently from the left value. It treats them both as equals, which, that makes some sense, but it's far more useful if we can kind of say that the right-hand values are the blessed values, or the ones that are special, they're the good ones, and the ones on the left are the bad ones, because it lets us do things like have a map function, just like you would have a map method, like a map method like you might have on a list. And I think most people are probably familiar with map on a list that says, if I have a list of A's and a function from A to B, I can turn that into a list of B's. We don't, in Scala, we don't have a map function on either because it doesn't know if you mean map on the right value or map on the left value. So the reason Scala Z has its own, which in this case is this left/right/. We have one, but we decided right/ is one that a lot of people don't like. It's a complaint that a lot of people have, that maybe the symbolic names aren't as good. And of course, that is, to some of us who are more math-y oriented or have been around the category theory a little bit longer, that kind of stuff, this is, the mathematical symbol for disjunction. So it makes perfect sense. But when you ask people who are new to all this stuff, it doesn't make as much sense. So what we're going with is XOR for an exclusive OR, saying you must be either on the left or on the right. And then Scala Z has this other one, which is left/ ampersand right/ to mean, which is an inclusive OR, which means it's either a good value on the right, a bad value on the left, or both. And so for that, we call it an inclusive OR or an IOR. And then validation is pretty much the same, but we decided that instead of validation, which would have values like success and failure, we decided to go with validated, which has valid and invalid. Otherwise, it's the same. We added, we have data types, which are, all of these data types are data types which are part of Scala Z. And they're implemented very similarly. We have one and, which is, one and is a something that abstracts over a non-empty list. A non-empty list is one that's very, very popular in Scala Z. It's because a lot of the times when people come to Scala Z, they come to Scala Z for the validation instance. The validation instance is one which it's a data type which allows, it's just like an either, it's either a successful value or a failure value. The validation data type allows you to do some nice things like, okay, you got an error, well keep going because maybe there's more errors and I want to get all the errors. So what it lets you do, it's very handy for doing something like form processing, where let's say we're going to make you fill out a form that says your name, address, date of birth. And then you get to the end of it and it says, something like your date of birth can't be in the future. And then you go fix the form and it comes back and you say like, your password needs to have a special character. And you redo it, it comes back and it says, and your password now has to have a number in it. And it keeps on, instead of making people keep refilling out the form, validation is a type which will allow you to say, okay, we'll process the form, we'll say, here are 5 things you need to fix about this form. collect all the errors. So this validation is one that is used very, very heavily. The reason I talk about it now is that the next one you kind of stumble into in Scala Z is that when you have a validation, we should collect multiple errors on the left. We know that if you're on the left or you're in the failure mode, we know that you must have at least one error or you wouldn't be there, right? It's either you have a successful value or you have a failure. And if you have a failure, I know you have at least one failure. So what we do is you might be tempted to use list, right? Just to store a list of all the errors. And then what you'll quickly be doing is something like saying, calling head on the list, right? But head on the list is an evil method. It should never have existed. It should never exist. You know, right? Why should list not have a head method? Who could tell me? Anyone?
It's not a total function.
What's that?
It's not a total function.
Not a total function, exactly. You could call head on an empty list and what happens? Boom, exception. And exceptions are evil go-tos. Then it's what you're going to say is you're going to start making apologies for saying, well, I know it's not empty, so I can call head this time. But it's one of those things where you're saying, it's just like a dynamic language where you're saying, I'm not going to use types because I'm better at keeping the types in my head than I am at describing them to the compiler, which is just a bad position to reason from. Grab the microphone.
So then,
Which is not on.
is the divide function also evil because it's not a total function?
Which one?
Division?
Division?
Yeah.
Sure. That's a good.
Why do we, basically what I'm getting to is where do we draw the line? Because if you start saying, okay, division is going to return options before we start learning rocks that you probably.
Sure. That's valid. Yeah, I don't know. That's a good question. Should division, since division is not total, should be allowed? And yeah, I mean, you got to figure out a line. This was an easy one. This is an easy line to figure out. Anyway, I went off on a tangent because I wanted to say that one and is something that is a type class which abstracts over these structures which have at least one value. So not only do we have a non-empty list, now we also have a non-empty vector, or a non-empty set, or a non-empty stream, or a non-empty anything you can dream of that has, you know, a lot of stuff. All right. There are some things that we're missing. This is a complete list. I was going to say that since I wrote the slide deck, it could be possible that some of these things have been implemented, and Writer probably has. Do we have a Writer yet, Delbert? No. Probably no. Okay. So these are stuff that we don't have yet. These are all things that we want to have. These are all things that we're missing from Scala Z. And every single one of these things are things that I use in Scala Z, and I wish we had them. The reason we don't have them is just haven't gotten to it yet. The biggest and the stickiest ones is task and process. Task is something that's part of Scala Z concurrent. And it is, if you're not familiar with it, and perhaps you're familiar with Pascal, it's the IO monad from Pascal exception. It's a way of controlling side effects. And it's something I use all the time. Because anytime I have a side effect, really all I need to do is wrap it in a task, and it's no longer side effecting. Now I've controlled the effects, and I have a task to return, which you could run and perform the side effects, or you could just not. So it doesn't side effect until you go do something. But I've gotten the side effects out of my code, because I can just change the task. So this is something that I use, and we at Verizon use everywhere. And a lot of people ask me, like, are you going to use cats at work? Do you use cats now? And the answer is no. I don't use cats yet. And I don't use cats yet because I don't have cats. Because I need cats. I can't do functional programming without cats. Because, like I said, eventually we need to write a row to the database. And eventually we need to read from the database. Eventually we need to read a file. Eventually we need to print something to the console. And if I want to do that stuff in my code, it can't be purely functional unless I have cats. So that's one that's specific. Process is another one that's like cat. Process is the main, is the central concept for Scala Z streams, which is a library that maybe you could say is operating in the same space as the Akka streaming. It's a similar thing where everything's a stream. It's a very, very beautiful way of programming, I think. I love it. If you haven't played around with Scala Z stream, find an excuse to play around with a little bit. Just as a side note, it's really fun stuff. We're using it all the time, again, at Verizon. And until I have that, I can't use cats. So, and I'm not alone here. This is the one that comes up all the time with all the people that are working heavily on cats. It's like, yeah, I can't use FOIA cats, and I can't use FOIA streams. So that stuff's going to come, and we're not sure how that's going to come exactly or when that's going to come. The author of Scala Z streams, the original author, there's of course a lot of authors now, but the original author of Scala Z streams, Paul Chiasano, is currently working on a refactor, and he's talked about trying to pull tasks into Scala Z stream and implementing himself the stuff that they use from Scala Z so it can be independent and add a way to make it compatible with cats and Scala Z and maybe structures, which is another project operating in the same space. So right now we're all kind of in the sit back, wait and see mode and just see what happens with tasks. We're hoping this refactor will get us tasks and will get us processed. If we determine at some point that that's not coming or not coming fast enough, there are lots of people kind of chomping at the bit who are ready to start working on those. Those are really tough problems, so it's the kind of thing where no one's going to go and re-implement tasks lightly. It's not like, it's, you know, there's a big difference between trying to say, I can implement a monoid for list, like I could, you know, all of us here could do that. I want to implement task, which controls side effects. That's a much trickier proposition. So we're not going to rush into that one and say we need it just because we need it. We're going to wait and see if we can get agreement on this one because it's a tough one. I kind of mentioned this before, but Scala Z has a bunch of data structures it's implemented, and they are just pure data structures. They're nice data structures. And a lot of these are improvements on data structures we have in Scala. So iList is just like a list, but it's not covariant. And covariant, what does that mean? Covariant is a way of saying that if you have a list of circles, you could treat that as a list of shapes because shape is a circle. Since circle is a shape, you can treat a list of circles as a list of shapes. That's the covariant nature. It means that as the type parameter of list varies, if it gets higher in a hierarchy or lower in a hierarchy, the type of a list of that type also travels up and down the same hierarchy in the same fashion. So as we go up the tree with going from circle to shape, we go up the tree going from list to circle to list to shape. That seems like a good thing to most of you, right? A lot of you might think, why would you not want that? The reason you would not want that is that what I can do then is I could say, take a list of shapes and add a cow onto the front. And now I don't have a list of any. And you never want a list of any. A list of any is not a useful type. Any is not a very useful type. Anytime that the compiler is inferring that a type is any, you've probably done something wrong, or you're about to do something wrong. And so, in order to have a cons operator that, you know, what we really wanted to do is have a cons operator that wouldn't let you all of a sudden change your list from a list of circles into a list of any. Right? So, iList is the invariant type that Scala Z implemented to handle that issue. It also does things like if there is no head on Scala Z's list. Going down, so if we go down from iList to maybe, it's a similar thing. Maybe is Scala Z's option. It's an option that doesn't have a get, because just like list not having a head, option should not have a get. And also maybe is, again, not covariant. The next one is Scala Z's map. That's a class that probably deserves some renaming. Going and then moving on, there's a finger tree, which is a data structure which allows for efficient appends, prepends, and dec or a DQ is a double-ended queue. These are things that we found in Scala Z that were either inadequate in the Scala standard library or missing from the Scala standard library. What we've decided for cats is that with the stuff that we don't want to tackle and we don't want to bite off. And we think that it would only lend to aim to bloat cats more. And so we decided that we're just going to say, you know what, probably one of us will start a separate project for that. And that just is work that hasn't happened yet. This is stuff I'd like to see done. I really miss having a double-ended queue, and I use that map all the time. So I'm hoping that it happens, but it's just something that's out of scope for us right now. One of the things that's been really refreshing and fun about cats is that it's really rare that you get something that's such a big set of ideas like Scala Z, which has been around for a long while and is in a lot of code bases. You know, a lot of people like me, if I started a new project in Scala, My default template for an SPT file definitely has Scala Z for it. I'm going to use Scala Z no matter what I'm doing. I'm doing it in Scala. So there's this huge amount of kind of inertia there, where Scala Z doesn't have the luxury of doing big refactors as easily as maybe you would like. So one thing that's been really fun about the CATS library is that we're able to go and say, let's try some stuff. Let's try some new stuff. Let's try some stuff that we always thought about might be fun. Because right now, no one, like I said, no one's really using it yet. Well, it's starting to get used, but right now we get to break the interface all the time. So we're getting to play around with some ideas and say, let's try it this way. And let it go for a month or two and say, okay, that way sucks, but I'm glad I tried. And so we do have some dead ideas out there. We made some fun experiments like having our either be left bias instead of right bias. Because some people thought maybe that's a much more natural to say, okay, well, what I'm going to return from this function is either a good database result or an error. And that's kind of more the way you talk. It's this, it's going to, the more the way people think about these things is that, the type I'm going to return is this thing, unless all this other stuff happens. And so people tend to talk about things as the good value first, what you think about being on the left. So we played around with this idea. A good friend of mine, Rob Norris, actually pinged me on 3 different social media things saying, Stu, I'm about to lay down in front of the bulldozer in front of this left bias thing. Because some people who were very, very used to, either's on the right, either the good value's on the right, that way in Haskell, if that way in the standard library, if that way in Scala Z. It was not very well received, but an interesting thought project. And it's one, again, I'm glad we went down that way and validated that we think we have it the right way now. We played around with having a shared sum type. So you have, the sum types, I mean stuff like you either have, that you have your, sum types would be things like an either, like a validation, like a exclusive or, maybe option. But a lot of these things are, if you look at the case class which implements these things, like either or validation or disjunction or our XOR, they all have pretty much the same implementation. It's like there's a value on the left, a value on the right, 2 type parameters which say what types they are, and they have a map function, this and that, and then all with a lot of the code becomes boilerplate from one implementation to another. So we played around with seeing, can we have just one implementation and then different type class instances, or can we have one implementation and different type tags or something, some way to share that implementation, which would give you a free way of saying, okay, now treat it like an exclusive or. But over here, I'm just going to, without mutating the code, just now treat that structure as if it were, a different sum type. Like treat it used to be a validation, and now it's an exclusive or. Again, the implementation ended up being scary, harder to read, and we ultimately pitched it. Okay. Any questions before we move on? Okay, so we'll talk a little more about the, no, skip that slide, skip these slides for a minute. Maybe we'll come back to that stuff. Okay, so another thing, along the same lines, another thing that's been fun about writing this new library is that we've kind of been able to play with the new tech, I guess, play with all the new toys that have been out there. And there's a lot of them. And we're kind of making use of all of them. We're pulling in the kitchen sink of Scala stuff, plugins and stuff like that, which I think is making the project really nice. And I'm going to talk about 2 of the ones that we're using that maybe you're familiar with. Probably won't be familiar with a lot of them, but I think that they've made the experience of working with cats and working in cats much more pleasant. The first one I'll talk about is Kind Projector. Kind Projector's been around for a very long time, actually. It's been around since 2.9 days. And it was, again, written by Eric. And what it does is gets rid of the really scary looking type lambdas. Who here knows what I mean by a type lambda? Yeah. Who here thinks they're awesome? Not very good. I think they're awesome because the type lambdas were a way that someone figured out how to do something that wasn't supposed to be done in Scala. So it was a way of where someone played around and said, hey, check out what I just did. And that's actually kind of useful. And no one expected that to work, but it worked. And what it does is, to talk about what a type limit is and how do you get into it. We're going to talk a little bit in depth about what a kind is. So we're familiar with types. I think, types, I'm not going to go into type theory definition of what types are, but I think we all, when I say, the types, I'm talking about types like int or string, and you kind of know what I'm talking about. Some types are different. We know when I say, we know when I'm talking about a string or an int, but list is not a type, okay? What we will say is that list is a type constructor. And you might think of it as a function in the type space. So you can't, for instance, take a value and tell the Scala compiler this is a type list, because it's going to say, well, list needs type parameters. You can say that this value is a type of list of int, but you can't just say it's a list. You can say it's a list of any, or you can say it's a list of A for some A, but I'm not going to tell you what, but you have to have that type variable there. You can think of list as being, again, a type constructor. You can think of it as a function that takes a type, like int, and returns a type, like list of int, right? So you can think of the list constructor, again, the type constructor takes something, another type, like say int, or like say map of string to int, and it gives you back a type. A lot of the type classes we work with in the category theory stuff, like monoid, not monoid, but monad, functor, they expect what they're parameterized on is they're parameterized on a type constructor. So when I say when I define a monad type class, I say it takes one parameter, and that one parameter is a type constructor, which itself takes one parameter. So what I can do for a monad, I can define a monad for list, but I could not define a monad for list of ints. All right? The definition says I need a thing that has exactly one type parameter. Okay? So what happens for something, let's say a functor? Again, a functor, it's not really important you know what it is, but it's something that has a map. Something that says I have, for some f, I have f of a's and a function from a to b, and I can turn that into f of b. Just like I have a list of a's and a function from a to b, I can turn that into a list of b's. That's the basic functor operation. Now, could I write a functor implementation for map? I'm talking about maps, like a map from strings to objects, or a map from ints to longs, or something, right? Could I write a functor instance? Well, I know I can write a map method that goes and says, takes all of the values and applies the function. So I could turn something like a map, given a map from string to int, and a function from int to long, I know I can turn that into a map from string to long. I know how that's going to work, but I won't be able to define a functor instance for map directly, because the compiler is going to say, functor wanted something that took one type parameter. It wanted, like, I have a list, I get an int, and I have a list of ints. That's a concrete type. With map, it's not like that. Map wants two type constructors, right? I can't just say map, because it's going to say, well, do you mean, you need to have one of those types already fixed. I can say, so I could define a functor that said, I have a functor from strings, that a functor which takes maps of string to something, and like a string to A, and a function from A to B, and turn that into a map of string to B. But I need to somehow fix that string and say that's not a type variable. I want to fill in one of those two, but leave a hole in the other place. So someone figured out. Someone was Jason Zog. Figured out you could do something like this. And what this says, so I used here, in this case, I used the exclusive OR, which is our either type. I use that instead of map, the map I was talking about before. But what we're going to say here is we're going to say, I know I can't define a monad for XOR directly because XOR takes two type parameters. What I'm going to do instead is do this crazy garbage. And this crazy garbage is the type land I'm talking about. So what we're going to do here is, if you see here, I've got curly braces. What that's doing is defining a structure, defining a class right in the fly. I'm just saying, this is just some class, I'm not going to give it a name. We're just defining a class. This class has one member. It's a type alias. It's a type alias that says that L of A is the same as XOR string of A. So what we're doing is we're saying that we're going to create this new type called L, and it's only going to have one type variable. And it's going to be the same thing as an XOR that has a string fix, and there's our type variable. Okay? And then this octal port, this hash sign or whatever, this pound sign, is a way of extracting a member from a type definition. So what we're doing is we're saying we're going to define an anonymous class. It's going to have one member, which is L, which fixes one type, leaves one free, and we're going to extract the L from that structure. And that's the thing that we're defining monad instances. So it's some ridiculous way that someone figured out of fixing one of the two variables. So now this thing is the right shape, and I get to define a monad instance. Okay? But that's really hard to lead. And to compound that in Scala Z, most of the time, that's done when people use Unicode symbols for the thing, and it makes it just a little more scary. So, now, this is used all the time in Scala Z. We could do, in this case, what we could do is just define our type alias over separately, right? We could define it just in some object, and we could refer to it as we could refer to it later, just refer to the type thing. It doesn't need to be inside some anonymous structure like we did above. And we could then define monad for string error up here, and that works just fine. The problem is that there are going to be places where I can't necessarily create that, I can't necessarily write this anywhere because I don't have anywhere to write it. The last line here is an example. Here is an example that comes out of Scala Z, that's the CATS version, but this is, I don't want you to necessarily understand this type signature, but what I do want you to pull out from this is that this is a type signature which over here takes a whole bunch of type variables of various shapes. It takes, this is a crazy looking shape, this is a crazy looking shape. But then what it does is it later says that I need you to implicitly pass me something of this type, okay? And this type, I need it to be this shape. I need it to have this hole. And I put it with a question mark here, and I'll talk to you what. But what I would have to do without this question mark is I'd have to write one of these. And I can't do it like this because I'm referring to something that didn't exist till I got in here. It's something in my type parameter. It's one of my type parameters that I need to curry, or I need to fix one of the types of it. So I can't define this outside of the method declaration like I did out here because I don't yet know what this is. Right, so since I have to do it referring to itself in the same definition, I have to write the type lambda. So, kind projector, what it does is, I've given some hints, the kind projector lets me use this question mark syntax. And this is something, it's a compiler plugin, very stable. Compiler plugins are maybe a little bit scary, but like I said, this has been around since 2.9, and it's very stable, and it just works. I've never had a problem I can attribute directly to kind projector. But what it would let me do is, it makes it so that if I were to write this version here, where I say, fix one side and put a question mark, the compiler plugin rewrites this to be this version, but you never have to see it. So we added this right from the very beginning in CATS. And since then, Scala Z is also added, and now Scala Z is using the kind projector everywhere. But I just bring it up I wanted to highlight this as just something that one of the many different plugins we're using, or kind of SPT plugins that or compiler plugins we're using, which are really, making CATS a much nicer experience to work with. You can see, would you rather write, the second line or the second to last line? And the answer is always going to be the second to last line. Next one I'm going to talk about is discipline. Discipline is a project that came from type level. Type level is kind of the umbrella which Scala Z used to live under, and it was kind of the pure functional programming umbrella for capturing lots of these projects like Scala Z Stream, Discipline, Monocle, the Lens library, lots of good stuff in there if you go to typelevel.org. This is one that was written by Lars Kupel, who used to be the maintainer for Scala Z. Discipline is one which allows you to check laws. It allows you to, and what do I mean by laws? When we're working with category theory, a lot of, I've described over and over again, or I've referenced a lot of times what a functor is and what the map function does. But I haven't told you the whole story. Like, we know the map function on a list takes a list of A, a function from A to B, turns it into a list of B. But that's not the whole, that's just a part of the story. The rest of the story is that there's some laws that have to go along with that. We can't just turn any A into A, B. There are laws that say, for instance, that if I do F map A, map B, that's guaranteed to be exactly the same as F map A and then B, the composite function of A and then B. And that's a law that's defined by functor that says, if you think you are writing a functor, this law better be true, and if it's not really a functor. And all of these, just about all of the type classes that we're implementing have some laws. And if they don't have laws, then we start to question if they're useful type classes. Because the law checking is what gives us the very handy property of being able to algebraically manipulate our code, which is one we like a lot because it allows us to do major refactors. Now, what do I mean by algebraically manipulate? Think back to when you were learning algebra in high school. Algebra was a way where we could take equations like 2x plus 1 equals 7 and be able to do things like say, well, I know I can subtract 1 from each side and get 2x equals 6, and then I know I can divide each side by 2 and get x equals 3, and I've now solved this equation and I learned something about, I've just been able to, when I'm doing this kind of thing, it's the symbolic manipulation it only works because we have some laws that say that what it means to divide both sides of an equality, or that I don't know what x is, but I know it's a well-behaved number. These laws are similar in that they allow me to treat pieces of my program as those variables in an algebra equation, where I can start to symbolically manipulate them and say, oh, if I have F map A, map B, I know I can change that into F map A and then B. And I guaranteed I did not change my program. I did not change what it would do at runtime because I know I have these laws to fall back on. So discipline, one thing that we are very good at about CATS is we have extremely good law coverage. So if anyone wants to come with a type class that they think should be part of CATS, it better have laws. If it doesn't have laws, it better be something that somehow else demonstrates such high value that we're going to take it even though it's lawless. There are some things that are tough to write laws about, but are still very useful. For instance, Haskell has a show type class, and it's really just a formalization of the .to string. Show is a way to say, if I have a show, I know I can call, if I have a show for a list, or a list of int, I know I can say .show on that, and I have a way of turning it into some string. It's a type of, but how would you write laws about that? It's not like functor where I could say, F map A, map B is the same as F map A and then B. There's no real laws about show. It's just turning things into strings. But it's pretty useful. So we'll make some exceptions, but one thing we'll do is we'll have very, very good law coverage. So discipline is something that allows us to write the laws in a very handy, convenient way. So for instance, here's that composition law I was just talking about. It lets us write just something that says F map A, map F map G is equivalent to F map F and then G. Just with that definition, and some plumbing behind the scenes that I don't want to show you because it's a little bit nastier, but we can write something like this, and then we can test these type class instances using Scala check. If you're not familiar with Scala check, that's another one I would say is a must read. It's a must know. You absolutely should spend some time exploring what Scala check does, but the gist of it is that it does property-based testing. So when you write tests in Scala check, instead of, in contrast to Scala test or specs2 or JUnit or one of these type of things, when you write those type of things, you tend to, we're hoping you come up with some good test cases, and we're not very good at that. So with something like specs2, Scala test, we might write something like, all right, if I take an address, I don't know, I'll just use my address. I use my address, and then we show it to the database, I get it back out, I should get the same address, right? But I'm really bad at generating test data because I always use my address, or I use my cat's name, or I always do this kind of stuff. The idea behind Scala check is that you'll define properties about your source code, like say, if I store an address and fetch it from the database, I get back the same address. But I'm not going to come up with the address. Scala check is going to figure out how to, or I'm going to help it figure out how to generate lots of addresses. And it's not just going to enter, it's going to first try your street name is the empty string. The next thing to do is going to say your street name is a string of 200 Korean and Japanese and Unicode emojis, and let's see how your database handles that. It goes very quickly to the awful cases, because it's a lot better at figuring out awful cases than we are. So the idea is that when we write a functor, we already have these laws, and what you'll do is you'll say, okay, I think I have a functor for list. Can you test it for me? And it will start generating nasty lists and trying to run functions against it. Make sure that any functions that you come up with, this property of composition holds. So what it lets us do is it lets us have a lot of confidence, again, that our laws are being followed because they're being checked, and it gives us, again, that algebraic manipulation of my source code. So I can look at it and I can say, I have a functor, I know I can do this. Or I have a functor, now I have a different functor. I'm not going to use list anymore, I'm going to use ilist. Or instead of list, I'm going to use vector. And it lets me, with a lot of confidence, just switch that out and have a lot of confidence in my source code is going to still work. And so this is huge for us, and anything that's going to make it easier for us to do this law checking is, a big, big win. Next one I want to talk about is simulacrum. So simulacrum, what it tries to do is it tries to make the process of working with type classes a much nicer, streamlined process. If when we talk about a very simple type class, semigroup. Semigroup, very simply, a semigroup is a way of combining two values. We can define a semigroup for ints, which says if I have one int and a second int, I can create another int by those by adding them together. If I have two lists, I have a list and a list, I can create another list by appending the lists together. It's just a way of saying I have a well-defined way of combining two something. Comes with laws that say that they must be associative, blah, 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 but this is basically all I want from a type class. Now, what I'm going to do is the only thing I'm going to have to add to this is I'm going to import the simulacrum library, and I'm going to add annotation to this to the type class I'm defining. I'm also added a type annotation to the method, and we'll talk about that in a bit. And I also left off the close brace. Now, what that does for us is just by adding that type class tag at compile time, simulacrum uses a macro to turn it into all of this. All right, and all of this is what, if you look in Scala Z, we're generating that by hand every time. Because this is all the stuff we want to have be there when we go to use this type class. Just, I'm not going to go over what every line of code does here, though, but what I'll talk about what some of this stuff does. This apply method is one that we use all the time. That apply method allows us to say that if I have it lets me refer to just semigroup square bracket list, or semigroup square group, semigroup square bracket int. And if there is one in implicit scope, it'll go find it. It's just a way of conjuring one without having to call implicitly, or it's just a way that you can say semigroup int, and that'll compile as long as it can find one somewhere for you. What it lets us do is adds these operations so that all this stuff is plumbing to be able to say that now, for example, there is no combine method on int, right? This is, like, int doesn't have a combine method itself. But I want to be able to write this. I want to be able to write, 1 plus 2, and this is the, we'll talk about that later. But I want to say combine 1 with 2 and get back an int. But, obviously we need to wrap this 1 into, we need to wrap that into some container which adds that method to it. You might call that, people used to call it the pimp my library pattern, and then we got quick collect, and then we call it the bedazzle my library pattern. But all of this stuff is there to let me just be able to write this code instead of having to, implicitly pull out a scope and then, do all the plumbing myself. I get to write this nice syntax. It's, and we get to do this, and this is really, it's beautiful. It's just great that we don't have to write all this boilerplate. And we get this nice interface. This is a much nicer way of working with it, right? So that's, yeah.
How will that play out with an IDE? I feel like IDE will be really confused by...
I'm sorry? How
well does it play out with the IDE? So I feel like IDEA, for example, would be super confused about macro annotations.
Yes, I need you to tell me, because I don't use an IDE. I think that what I understand is that things are getting a lot better in IDEs with macros, but yeah, I'm not going to be surprised if this confuses your macros. I honestly have never used an IDE. I didn't, you know, you're BIM. Anyone? I don't know. I need someone to, yeah.
So when you're using Scala set and presumably text, the IDE actually handles that pretty well, but possibly if you're developing CAT itself, you might run into it.
Okay.
Yeah, macro annotations are fine.
Yeah.
Intelligence added vector support, so it's always that. Intelligence added vector support.
Okay.
So there's some support, but not for this.
And this is, so now, I talked a little bit about this with other people beforehand, but I'll say it again. You know, there's two different flavors of macros that come. There's white box macros and black box macros. Just a really quick, what that means is, there's multiple flavors, but there's one, the black box macro is a macro where I'm going to write a function, and I'm going to tell you the input types, and I'm going to tell you the output types of the function, but I can't tell you what the function is going to look like until compile time I get to do stuff, and then I implement the body of the function. Those are the ones that are blessed. They're the ones that were first accepted into 210. They're the ones that are not experimental in 210. And that was done for the IDEs, because the IDE can look at that type signature and not need to expand the macro to know what the type of a call to that method is. Right? Those are the black box macros. We can treat them like a black box. I don't need to see what the macro is. Those, I would expect your IDE does pretty well with them. Then there's white box macros where I'm going to lie about what the return type is. And I don't know what the return type is to like compile my macro. Then I know what it is. So that means that the IDE needs to run your macro, which is asking a lot more of the IDE.
I mean, in this case specifically, if you're using macro notations to actually add new methods that the IDE needs to use to actually know about them.
Right, and so this is one where we're using what is a, which we need to pull in the, what is it called? The Paradise project, which is like the stuff that would be Paradise, so we could use all this stuff, but this stuff isn't making it into mainline Scala for a while. And that's the type provider support, which is that we're actually, our macro is not only just, you know, enhancing this a function, we're actually providing new types to the compiler. And so, again, the IDE would have to be able to run the macro in order to even know what types we're even talking about. So I expect that this would not necessarily be the happiest thing in your IDE, but I don't know, honestly, I don't, and most of the CATS maintainers don't use IDEs either, so it's one of those type of things where it's, we need you to come and help and tell us what we're missing and stuff like that. Okay, so next thing I want to talk about is one that is huge for me, and is that, and this is one that I added and I spent a lot of time. It wasn't hard. It was hard to get going, but now it's easy to add your own project. And that's that we have compiler verified documentations. Again, this is huge. And what it is we're using primarily the biggest win here is that we're using this library called Tut. Tut comes from a guy named Rob Norris. Super nice, friendly, easy to work with guy. I encourage you. He's T-Polecat on IRC and on Twitter. If you ever have a problem with Tut, you should reach out to him. He'll fix it right away. What Tut does is allows you to create markdown files. And inside markdown files, you know, you might have a code block, and you might create a code block with backtick, backtick, backtick. And you put some code in there, and it's, you know, when it gets rendered into a monospace font and that kind of stuff. You can also say backtick, backtick, backtick Scala, and that will tell some markdown renderers also highlight the keywords in blue and highlight the variables in red, or you know, whatever. It lets you say, this is not just a code block, this is a code block for Scala code. What Tut lets you do is it lets you mark a section not as Scala, but lets you mark it as Tut. Then there is a compiler plugin that runs through that markdown, finds those sections that say Tut, starts a REPL session, inserts your code in the Tut block in the REPL session, and then puts it back where the Tut block was. It basically compiles your markdown file into a new markdown file with the Tut sections replaced with Scala sections that have been run through the Scala REPL. So you'll see a REPL session. You don't have to write. You don't have to interact. You'll write your markdown, and you'll see a REPL session in your docs when you're done. And if the REPL session breaks, the build breaks. And this is huge, because it means our documentation can't get out of date. So if I decide I don't like a certain method, and I remove it, but the docs were referring to it, or if I rename a method, or if I add a parameter to a method, the next time I go to compile, the next time Travis goes to build, and it will fail, and it'll tell me exactly where my docs are at. So I won't even be able to put a pull request in if I've broken the documentation. And I think this is an absolute huge win. But it's not just TUT. We're also using Unidoc. Unidoc is just a Scala doc, but it's Scala doc that knows how to reach into all your modules. So that we have a CatScore module, we have a Cat standard module, we have a Cat free module. What Unidoc does is it makes it so that we have one Scala doc site that covers all the different compiler modules. SPT site takes the output of both of those previous things and generates a Jekyll site for you. SPT GH pages then takes that Jekyll site and pushes it out to your GitHub pages so that you have a rendered website on GitHub, which contains all of your documentation, including the compiler verified stuff by TUT and your Scala doc, and they can all refer to each other. I encourage you to check out the website. It's almost entirely authored by myself. And I am not a web developer. So I've tried to make it pretty good, but it could use some love from someone who knows CSS and HTML and stuff better than I do. But what I have done is I got onto grading, we had a documentation website within the first week of having a project. And that's very important to me that we have a documentation website. And what I'm trying to put out there is we're putting examples that can compile for us. We're trying to put also just rudimentary stuff about what is a functor and how do you use it. What is a monad, how do you use it? Because that's stuff that's missing from Scala Z. When you go to Scala Z and you're like, okay, they're talking about monad. I don't know what a monad is. It's really hard to necessarily go find a definition of a monad. They want you to go somewhere else. They want you to go to NCAT Lab, or they want you to go to Haskell Type Classipedia or something like that to find that stuff. But we're trying to come up with examples and get that all stuff on the website. Again, like I said, I made the website by getting, they say you get 1 million monkeys in a room, they'll write out Shakespeare eventually. I found that with CSS, there's a limited language, you only need a couple hundred monkeys, and they'll bang out some somewhat working CSS, and then, I got something up there, and then the very next, as soon as that pull request emerged, people were saying, well, it doesn't look good on my mobile phone. I was like, all right, honey, get my monkey bag, we're gonna have to go harvest some more monkeys, and then I rewrite the site again, which I did. So it's out there and it looks good on your mobile phone, but it needs a lot of work. So this is a place where I'd love to have some contributors. I'd love to have some other people coming out and helping out. It's a really easy way to get started because it's easy to do. And our compiler will make sure it's all verified for you. So here's a better example. My slides are a lot more. Here's a better example of what using TUT looks like. So this is something I might stick in the middle of my markdown file. When that's compiled and put into the site itself, it gets turned into this. So this is what the documentation will actually get. This is the documentation I write, and this is the documentation that ends up on the website. So we've actually run the Scala REPL session, and we've seen the results. So it looks like a real working session. Sometimes you want to write stuff that doesn't actually work, right? You want to actually write broken stuff and use that to document ways things don't work. There's a no-fail option that says, this won't compile, and this doesn't compile, that'll be a compiler error. What will happen is you'll see a REPL session of you typing this broken stuff out and see an error coming out of the REPL. You can also say TUT silent, and that does not turn this into a REPL session. It does run it in a REPL session, make sure it runs, but it doesn't alter that. This will just turn it into a Scala block, and it'll show up in your documentation just like that. But we still get the property that if you broke it, it'll break the build. So this is a way of checking that the code is correct without actually showing the output of running. Okay, so I'm not even going to talk about our definitions. I'm going to skip that. All right. So this was our roadmap a month ago. The last time I talked about it was that we need to publish a release, and we need to find a new home. We are now publishing releases. We have Travis is building releases. Anytime we push new stuff up, Travis builds and makes a snapshot release. So that part has happened. You can actually add this. It is published. You can add it here. for our SPT project today is the library dependency, and as well, you know, that's good. So we got that one done. Next one is that we need to find a home. Right now, this is under Eric's personal GitHub repository, and it makes some things a little bit awkward with, we get to see his work in progress branches alongside the master and stuff like that. This really should be moving under some bigger projects site, and we just haven't done it yet. Might end up under type level, it might end up under a CatScore project itself, could end up somewhere else, but it's probably not going to stay in its current position for too long, which is under Eric's personal GitHub page. And that's just one that we haven't just figured out where we want it to live, and I think it's going to be type level. We haven't figured out who gets permissions to the build and how the Travis credentials work and stuff like that. So that's one that I think will change relatively soon. All right, so wrapping up, I'll talk about how to get involved yourself. What we've put some effort into doing is to try and make sure that we're really making use of as much as possible all the features of GitHub for managing a project. So we are being very heavy and very active on pull requests. We have rules that say that we'll never merge a pull request that doesn't have at least 2 committers giving thumbs up on the pull request. There's lots of discussion that goes on the pull request. We encourage people to submit pull requests that are half-baked, and we have big, long discussions on them. You know, I have been one to throw a pull request in there. I don't ever want to have merged. I just want to stir the pot a little bit and get some discussion going. We're making heavy use of the GitHub issues, and under the GitHub issues, we're making heavy use of labeling and tagging bugs. So we do have bugs. I try to make sure we always have bugs labeled as low-hanging fruit, which are bugs which I think that you as a newcomer could come along and say, hey, this stuff is there, and you could probably figure out how it works. We're missing some Scala doc. Or, you know, there's a lot of the times they are documentation related. It could be test related, like, hey, we have this one AND class, and we have this, you know, these 5 methods are covered by test, but this other one isn't. We have code coverage tools out there. Every time someone submits a pull request, we get a delta that says this pull request, if you merge it, will change our test code coverage level from, I think we're about 60% now to 60.1%, or to 55%. You know, we're trying to use the process. We're trying to use the social collaborative process that exists on GitHub, and we're trying to make very, very heavy use of it. So if you want to get involved, come to our issue tracker, look for low-hanging fruit. Look for bugs that are tagged as ready, which means we're ready to work on them. Look at ones that are tagged as meta, see if you have any insight. We're tagging things as meta when it's discussions about how the project should move forward. Stuff like, should we add the maybe class to the ILS class? And jump in, join the discussion, because you people, as people that are not involved in the project, are the most important opinions out there. Because again, one of our, you know, one of our prime goals, like I said in the beginning, is approachability. So, you know, although I know what I'm doing with a lot of these type classes, and they make sense to me, if you come along and say, this part I think is a little confusing, you're the person I want to hear from much more than some of the other committers, because I know all the other committers get it. But we value your opinion very, very highly. We're on Gitter. That's where all the discussion is happening. If you're not familiar with Gitter, Gitter is basically a chat client that's built around GitHub. So you join with your GitHub credentials, and there are chat rooms based around the GitHub projects. All of the conversation happens in Gitter. There's no GitHub channel. So if you want to talk to us, you talk to us on Gitter. And please come and talk to us. Tell us what's missing. Ask us questions. There's no dumb questions. It's an extremely friendly community who, you know, we're all working towards this common goal, and you are the common goal as the person who's not using cats. You know, so please come along and don't be afraid to ask questions. If you come and ask a question, again, if you don't like, again, we'll fix it. If someone's saying something, you think they're being aggressive with you, they're calling you stupid or blah, 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 tell me, I'll fix it, I promise. So yeah, try it out, get involved. That's about all I think I'm going to cover for now, but questions, happy to answer. Yeah? Do you want to, should we get this? Let's pass a mic around if this one's working. Hello?
So it's okay, I got it. So it's more a question about describing functor and monad. So those concepts have nothing to do with Scala. It's algebraic topology, covariant, contrariant functor. covariant, contravariant functor, and the kind projector is called fast caller home functor. So I am struggle to present those terms, which is topology in programming. It doesn't make more sense because Scala just translates those concepts in code. It does make more sense to present those concepts. There's the same problem with Scala, is to present those concepts. Here the topology, this is a contravariant, covariant functor in math. It's just here the translation in Scala, then try to describe, because I have the same problem, the struggle that to describe mathematical concept of algebraic topology in using programming in code, which is very difficult. Just presenting, just here, this is a math, like an equation. This is a math, and this is just how you just write in Scala. And when you do that, it's very straightforward. It's very, very simple.
Yeah. Was that a comment or was there a question?
No, it was my question. Does it make sense to present the maths first, get a monad, comonad, contravariant functor, bifunctor, and so on, and how it's just described in Scala, and then to describe through the code?
My tendency is to say that with a lot of these concepts, like functor, for instance, these are concepts that we're really bastardizing when you're coming from the math. Okay, and a lot of these things, our functor is not a mathematical or category theory functor. When you talk about a functor, when you talk about it in a mathematical sense, a functor is, a category and a mapping from one category to another, right? Where a category is a set of objects and arrows between them, and we're mapping from the objects to objects and arrows to arrows, right? When we're writing in Scala, the category is the objects are types, and the arrows are functions between them, right? So a functor is supposed to be a mapping from a category to some other category. But the only category you ever work with in Scala is that the category where types are objects and arrows are functions. Objects are types, not arrows are functions. So all of our functors are really endofunctors, right? When you talk about all of these things, we're just slightly bastardizing them. So when you if you try to talk about them in the pure mathematical sense, how do you introduce functor and say we map things from one category to another, but just like one category? It's all, to me, it tends to be. The more you introduce the pure mathematical concept, really purely as it exists in math, I think the more you have to apologize, which I hate doing. I hate having to say, well, look how nice this is in Haskell, but then in Scala we got to write it like this. I tend to just say, here's this concept that relates sort of to, I think I find better traction if I don't muddy the waters with here's the pure mathematical concept, because it's not what we're going to be using. And I'm not sure if it really helps. I think I get much more traction from saying something like, that map method on list? It's like that. And then farther down the road, months into this, I can say, all right, now let me tell you what a functor now that you get it, I can tell you the category theory behind it. I think that, in my experience, I do better that way. I don't know. Because we all know what that map method on list looks like. But I don't want to have to then start from, okay, objects, arrows, morphisms, that stuff, as soon as I say morphism, I've lost half the audience, right? More questions?
So I think it's awesome that CATS does the code coverage stuff and also publishing every release, because you make a contribution to like Scala Z, and it's not immediately published, so that's kind of an issue. I'm wondering if it's possible to have like a G8 template, because I think like all future Scala projects should kind of have this like always publish a snapshot version, and like why not comment on GitHub to get the code coverage. So I kind of wonder how much work was it to get all this cool stuff into CATS, and would it be possible to do a G8 template so like all other projects it's like pretty easy to.
Oh, you mean so other projects could use, for instance, simulacrum and discipline? And
no, more like the publishing every release. Okay. I mean publishing every commit. Yeah. And also the code coverage and commenting on GitHub. That's like super general. Yeah. A bunch of us have been talking about it a lot, and we've talked about
And I think it's not just the publishing, like I tried to do it for all of the doc publishing stuff. I didn't take, like what I did for that is after I got that all finally working, I created a new project which had like one class in it, it had one method in it, but had all the documentation plumbing was working. That's on my GitHub. I think I called it Indoctrinate. So I've done that a little bit. I don't think people have talked about doing it with the Travis build and stuff like that, but what we've been talking about, which I think is a pretty exciting idea, is to make kind of like a good stuff plugin, an SPT plugin that would be like, include this SPT plugin, and then you're gonna have all this stuff, you'll have access to SPT site and all that stuff, you'll have access to Simulacrum, you'll have access to Discipline, you'll have access to Machinist and all these other plugins, and we could do the GitHub plugins like that. So I think that's what you might see coming out of this kind of quickly. Miles and Eric and me and a couple other people are talking about trying to come up with a blessed plugin, kind of like the plugin to end all plugins. That's probably where, and if that's probably where something like the Travis build stuff will integrate in. Unfortunately, a lot of the Travis stuff is kind of like stuff you do out on Travis, which is like, the hardest stuff about that is like getting credentials put out there so that Travis knows how to push the bin tray, or Travis knows how to push the soma type. Like that's the stuff that you do. Like I don't know. There's not much work. Most of the work is out there. It's not inside your build, unfortunately.
So this is really a fair question because you skipped it your slide, but you spoke, or you had a slide on one of the open questions was type plus coherence. And I know what Edward's opinion on this is, but I'm curious what yours.
Yeah, okay. So what is type class coherence? Type class coherence is the idea that if we have an instance for a type class, there's always exactly one. So we talked about the semigroup for ints, and I said that we have this combine method on semigroup, which says, given an A and another A, I can combine them and make an A. And so I gave the example of a list and a list, I can append them together and get a new list. For an int, I can make an int and an int, and I can add them together and get an int. I can also take an int and an int and multiply together and get an int, and get the perfectly valid implementation of this type class. It follows all the laws, the laws being associativity, basically the only law is associativity. I can multiply numbers in an associative way, or I can add them in an associative way. Now, this is a big problem for Haskell. I'm not going to say it's not a big problem for Scala, but it is a big problem for Haskell. In that, in Haskell, the way in Scala we use these type class instances, we tend to pass them around implicitly. So we have some extra implicit parameter block where the type class instances go, and that's how we pass them around. In Haskell, the whole idea of type classes and type class instances is built into the language itself. It's a first class concept in Haskell. So you don't necessarily get control over how they're passed around. They're just there. Now, if you have one piece of code that's talking about a semigroup for ints, you really need that to be the same one everywhere. So if we're talking about what is the semigroup for ints, I can no longer say this semigroup for ints, this one that adds, or this one that multiplies. There's just one. So what I need to have happen in Haskell is I need to make sure that everyone who's talking about a semigroup for ints, they're all talking about exactly the same one. Because if you're talking about the multiply one and I'm talking about the add one, stuff could break. Now, is this a problem for Scala? Well, it's certainly bad if you're talking about the add one and I'm talking about the multiply one. But in Scala we have, since the way that we pass these things around is not a first class thing, it's an actual parameter that is a parameter to a method. I do have some control in that I can pass that explicitly. So I could say for this block of code, I'm going to use the multiply version. I'm going to pass it in there and make sure that all of these things are using that multiply one. But you can still get tripped up. You can still have someone down the road who tries to pull it out of an implicit scope and doesn't get the right one. Now, we've talked a lot about whether or not we want this type class. We want to force this type class coherence because if we had complete type class coherence, there's a class of bugs we could avoid. However, multiplying ints together is actually really handy, you know, and there's times when we want some other type class. And so the question is, what do we do? In Haskell, what you do is you create a new type. So in Haskell, you might say, okay, when the semigroup for ints says that we add them. But if you want ints that multiply, we'll create a new type that just is in Scala, you would maybe make a thin wrapper. You would make like a multiplicative integer or something, and you'd wrap all your ints in this, and when that's some separate type, so it gets a separate type class instance. Because now I'm not looking for a semigroup of int, I'm looking for a semigroup of multiplicative int, and the only one that's going to exist is going to be the one that multiplies. So we can do this. This is what we do in Haskell. We do it in Haskell for free. We do it without any overhead at runtime. In Scala, once you talk about boxing things, you have to be really careful about how you box things so you don't incur an overhead at runtime, and sometimes that's really hard. So one option in Scala is to do that, is to do the new type thing. Say there's only one for every type, and you got to create a new type at the possible runtime expense. And one thing that Eric, the guy who started this project, does not like is runtime expensiveness or boxing and stuff like that. So he's tend to shy away from that. One of the more promising things that we're looking at is that Miles Sabin, the author of Shapeless, and Mike Pilquist, the author of Simulacrum and S-Codec and a few other things, have been looking at a macro which would allow for local type class instances. So some way of saying that there's only one type class instance, except this local, I'm going to say inside this context, we're going to switch the int to a multiplier, from an add to a multiplier. So I think that Mike Pilquist has that macro somewhat working. It was a little bit janky the first time he wrote it, but I think what we're kind of hoping for is that we're going to try and not be too prescriptive, but we're hoping that his macro will allow you to kind of do all of the things you might want to do, which is to say that we're not going to allow multiple type class instances, but you have this way of locally, you can say just for this code block, we're going to pretend that it's a whole new world. So that's kind of where we're waiting on. I think that was one type class instances. Type class coherence was one where there were kind of a lot of opinions, but not a lot of strong ones. And which is something I've found a lot in the past project. It's kind of like, I'd like it to be this way, but if you really feel strongly about the other way, like, yeah, whatever. So that was kind of one that kind of landed in the whatever. It sounds like Mike's got a good background. More questions?
Given the current state of cats, or which use would you recommend it?
Which what?
Or which uses would you recommend it? Use in production or just for distribution only? What is?
Yeah, I would be definitely hesitant to say go throw this into production because you might be the first person to throw it into production at this point. Now that being said, I do have a lot of confidence in it. People, we have a lot of open issues on GitHub, but very few of them are bugs that are bugs like I run this and it doesn't work right. The bugs that we have are bugs like theoretically I could bypass one of the laws if I do this nasty thing. There's stuff that are the bugs that we have are more like I think that this implementation might not pass a law, but it's something you're probably not going to expose as a bad. It's not going to be the type of thing where I run it and it crashes, or I run it and it blows up memory. I don't expect you're going to run into those type of issues, but then again, you're going to be a pioneer, you're going to be the first one using it. And that all goes back to how, again, the people who were motivated to write this library are the people who were very motivated to do pure functional programming all the way down, and we can't do that without hats. There's stuff that's missing still. So, and I would be very quick to use this on a personal project. I just don't happen to have a lot of personal projects going on right now because I have a lot of shit going on at work and I just don't have time for that right now. If I was going to create some kind of fun little project on the side that wasn't something I work critical or mission critical, I would use it in a second. But there's still stuff missing. But it's getting good. And I think that Travis Brown just threw up a library where he ported a JSON library to use cats from, he ported Argonaut and John. Was it Argonaut? No, it was John. It was Eric's. What? It was Argonaut? So he ported Argonaut, right. So he took a big JSON library, a very, very good JSON library, ported to Scala and cats. He's it's starting to happen. I think now we're going to very quickly start to see the ramp up of all of a sudden cats projects will start showing up. Right now there just hasn't, that's like one of the first big CATS projects to show up. So we're just, you know, you're going to be a pioneer. But I think we're ready. I think we're really ready for it. It doesn't scare me at all that people are going to start using this in the real code. Because again, we do have really good coverage, test coverage. We have very good log coverage. And again, look at some of the pull requests that have been merged and look at the level of scrutiny that they get. And again, it's not scrutiny like, hey, you're screwing up. It's scrutiny like, hey, it would be better if. It's very friendly conversations, but there's a lot of scrutiny that goes on. So I have a lot of confidence in the code that we're putting in there. It's pretty solid. And if you look at the people contributing, you'll see that it's a very solid group of contributors. You know, there's a lot of who's and Scala library authors who have shown up to the party. So does that answer your question?
Can you use CATS and Scala Z in the same project?
Yeah, well, you're going to get, sure, there's no reason why you couldn't. You're going to have to deal with the namespacing. We have a lot of clashing names. If you go import cats._ and Scala Z_, you're going to have two things called monad, two things called monoid, two things called this and that. If you want to deal with the namespacing, there's no reason you couldn't.
So could you use CATS for everything but task and then use task?
Yes. Yeah, I think so. You know, the problems are going to come up when you start to say, okay, it's not just a task, it's really an option T that has a task on the inside, or I mean a task on the outside, and now option T says it works for anything that's a monad, but I have the one thing as a monad from this library. And so it's going to work on a thin layer, but you won't be able to do everything for sure. Things will, I think you'll very quickly run into, oh, but this is this monoid and that's that monoid, right? But there's nothing technically stopping you. That's it. More questions? Good? All right, again, my name's Stu. You can find me on GitHub, you can find me on Twitter, you can find me on, find my email. I love talking about this stuff, so I'm happy to talk about people, talk about this again, continue to talk about this with people tonight, or find me online, and please come check it out, join us on Gitter, see if you can help contribute.